بسم الله الرحمن الرحيم. الحي أهلا بكم أحبتنا في درس جديد يتعلق في الدروس أو يتعلق بالمحاضرات السابقة أو الدروس السابقة، وهو درس تكميلي كذلك لدرس أو للمحاضرة أو للدرس 19 أو للدرس 20 كذلك، بطريقة حساب المعدل الوزني للوزن الجزيئي للبوليمر عن طريقة تشتت الضوء. بطريقة تشتت الضوء، طريقة مهمة جدا، طريقة نوعية لحساب المعدل الوزني للوزن الجزيئي للبوليمر. So here we are once again, ladies and gentlemen, here, and brand new methods or brand new complementary lecture here talks about mostly associated with the calculation or even the empirical computations of the weight, average molecular weight for polymers here by using the very specific and very accurate method here to be represented or even to be visualized by using the current review, which is mostly or mainly associated to the light scattering. The method is actually called light scattering methods in the calculations of the number of, or even the calculation of the number of molecular weight, as you can see right here for you. Light scattering. The method is actually going accordingly to the scattering of the segment of the incident light for the polymer solutions, and the light scattering is due to heterogeneity. Due to the heterogeneity of the polymeric solutions, due to the polymer molecules mobility or the polymer molecules kinetics. Thus, or therefore, there will be a continuative shift in the localized concentration of the solutions, leading to a change in the refraction factor or even the refraction coefficient. Consequently, the light scatterings and the intensity of this scattering or even the intensity of dispersion is pretty much polymer molecular polarity and solution concentration dependent. يعني طريقة يتم فيها تشدد جزء من الضوء الساقط على محلول البوليمر، تشدد الضوء الساقط وليس جزء. الضوء الساقط على محلول البوليمر، ويعود تشتت الضوء إلى عدم تجانس محلول البوليمر. يعني هناك مناطق يتشتت فيها الضوء وهناك مناطق ينكسر فيها الضوء ويتخلل المحلول البوليمري. Means there's actually a very specific regions at which the light beam or the light ray incidence on the surface of the polymeric solution of the polymeric solutions is actually pretty much used to be refracted at some regions, and some regions the light will be scattered. They're scattered at a certain mechanism or at a certain pattern or even at a certain manner. يعني هناك بعض المناطق يتشتت فيها الضوء بنحو معين، وهناك مناطق ينكسر فيها الضوء ويتخلل المحلول البوليمري. There are actually regions at the polymer solutions while the incident light is actually penetrating the surface of the solutions, polymer solution of course by the way, so it will penetrate right through the solutions, right to the bulk or right to the core or even to the bottomizations of the, or even to the bottom of the solutions of the polymer material. Though actually we'd like to calculate the weight average molecular weight too by using the light scattering method stipulated here for you. So the given equation here actually stipulates or even stipulates the refraction or even gives the empirical results, or give the empirical optimization here. Empirical arithmetical optimization for the disruption or for the turbulence coefficient, as you can see right here. For turbulence coefficient is expressed by tau, the Latin prefix. By tau, the Latin prefix equals to ln I to I naught to L. Ln I naught by L, or ln I naught by L, as you can see right here. Terminology or even the term significance are visualized or even as are commonly formed or even commonly disambiguated in the following form. I is dispersed ray intensity. Dispersed ray intensity يعني شدة الإشعاع المتشتت أو scattered ray density. Scattered ray density intensity. I naught is the incident ray density. Incident ray intensity. I naught. L is the travel distance and to the polymeric media, or the travel distance to the polymeric media. المسافة المقطوعة في الوسط البوليمري أو في المحلول البوليمري. كما ترون أمامكم. دلالة الحدوديات، دلالة حدوديات المعادلة. Tau as we indicated before or as we stipulated، يعني tau كما أشرنا أو كما منصوص عليه. Tau is the turbulence coefficient معامل التعكر, which represent the difference between the resultant turbulence of the solutions to the resulted turbulence of the intrinsic solvent or the pure solvent. يعني يمثل الفرق represents the difference between the resultant turbulence of the solution يعني التعكر الناتج عن المحلول to the resultant or the resulted turbulences of the intrinsic solvent أو تعكر الناتج عن المذيب النقي والذي يساوي النسبة بين شدة التشتت which equals by the way the ratio between the dispersion or the scattering intensity to a disk surface with a diameter r about a dispersion source or about a dispersion emissive source as well as the intensity of the incident light beam and the intensity of the incident light beam الذي يساوي نسبة بين شدة التشتت على سطح قرص قطره r حول مصدر التشتت وشدة حزمة الضوء الساقط. الضوء الساقط كما تبنى tau equals to 32 by cubic and as you can see right in front of you to the cubic square or to the power square or to the power 2 3 lambda n is the refraction coefficient n big or even n capital here equals to the molecular amount or the molecular weight or the molecular number. There's actually a proportionality equation required to be mentioned. يعني هنا معادلة تناسب يجب أن تذكر. A proportionality between the turbulence coefficients as well as using the concentration molarity and the weight average molecular weight. يعني علاقة تناسب بين معامل علاقة التناسب تربط or yoked or even linked by using a proportionality constant which is the h high by the way as you can see right here on the denominator the proportionality constants between links or even yoked between the turbulence coefficients أو المعادلة التي تربط بين معامل التعكر turbulence coefficients معامل الاضطراب و التركيز المولاري C here the molar concentration of the molarity and the denominator as you can see right here or the denominator and the denominator the C is the molarity and the as well as the weight average molecular weight as you can see right here. So the proportionality constants is actually proportionality constants and the tau which is the by the way the coefficient just like we say indicated before and the tau and the proportionality constant both of them will be at the same hand side of the equation which is left by the way. So the left hand side of the equation is actually and the right hand side of the equation. Right hand side of the equation is actually consists of two segments or even two segments like you see right here in front of you separated by a plus sign separated by a combination sign. لذا هناك جهة أيسر المعادلة وجهة يمنى المعادلة. الجهة اليسرى ثابت التناسب ال H at the left hand side of the equation the proportionality constant H and at the right hand side of the equations the molarity as well as the average molecular weight or the weight average molecular weight as you can see right here in front of you and the molarity or the molarity concentration of the polymer solutions required to measure the number of or required to measure the weight average molecular weight for by using the light scattering method. The tau is the turbulence coefficient we require to measure or even to require to gauge the weight average molecular weight right for. So the term significance is as follows or the terms significance are as follows. يعني دلالات الحدوديات المعادلة أو دلالات شروط المعادلة هي كالتالي. H the proportionality constants. Tau is the turbulence coefficient. C is the molar concentrations as well as you can see right here in front of you. Here are very important topics to be mentioned or very important topics to discuss or individualize here which stipulates or it states even that the methods or very important synthesis or very important very important visualization or picturization here to disambiguate and explain the methods to control the molecular weight of the polymer. Methods to control the molecular weight of polymer. The molecular weight of the polymer in the condensation polymerization technique is controlled by using two methods: the rapid cooling or the sudden cooling, B the change of the the change of the reactant monomer ratios. The change of the reactant monomers, just monomers, without ratios. Ratios way too great a word to mention circumstances we're actually dealing with right now, as you can see. يعني نسب لا تذكر هنا نسب لأن rapid cooling here, as you can see right here for you. Since the degree of polymerization that determines the molecular weight of the condensation polymerization is pretty much the polymerization time dependent, so thus therefore it could be possibly to get the molecular weight, the appropriate molecular weight, by rapid cooling for a mixture of polymerizations, or for a mixture of polymerized reactants, but the polymers or the resulted polymers with this way will be stable if it was exposed to heat again, or if exposed to a second round heat, will cause a side, or even cause will result in acid reactions, may affect the, as you can see right here. B. Change of the reactant monomers. The molecular weight of polymer can be determined that by using the monomers, number of the amount of the very effective or very functional groups reacting will be equivalent. So when proceeding at polymerizations, the polymerization reaction will keep going till so the polymeric signs will be capable of reacting and relate with each or keep bonding with each other, or relate to each other. Thus, the polymerization will be, as you can see right in front of you. With this method, we can prepare a very specific, almost approximately a specific molecular weights. The polymers prepared by this method will be stable because due to the functional groups and at the end of the polymer chains, which may take part in the secondary reactions or the collateral reactions at the appropriate circumstances or at the appropriate conditions. When prepared, the polyamides of the diamine compounds and the dicarboxylic acids, as well as this. So, in case of using an overflow of diamine, polymer will be formed with the entire polymeric chains with its entire polymeric chains will be formed, or will ends up with amino will be started, or even will be commenced with amino functional groups. Thus, the series will not, or even the as you can see right here in front of you, the chains will not take any action, or not take any action in any further reactions after the acidic groups, as you can see right here in front of you, are converted to amidic or amidian groups. So the chains will take part, or even chains will take action in any further reactions after the entire acidic groups are converted to amidian groups. Here's, as you can see right here in front of you, a very important topic to refer to, which is called the plasticizers. Plasticizers are actually a bonding agents, or even a very particular functional agents that actually used to be added to the polymeric solutions, or to polymeric stiff or even very hard materials. Oh, the hard, not stiff. حاجة stiff والله. The hard materials, to convert them, or even to shift their phase that actually they actually going with into a whole different phase of mass, or even fast phase, to a whole different mass phase, as you can see right here in front of you, such as from the solid phase or into the liquid phase. The plasticizers here to use to soften and not soften, but we're just going to say added more plasticity, or introduce more plasticity. Here comes the name, or here comes the terminology of plasticizer from. So they used to introduce the more plasticity right into the compound, or even to component of polymeric chains when added in order to satisfy certain requirement, or in order to be used in certain applications. يعني المولدينات تضاف مواد إلى البوليمرات عادة في الحالة السائلة وكقاعدة. يعني تضاف إلى البوليمر لتلبية غرض معين أو لحاجة معينة، يعني لتلبية متطلب معين أو للاشتراك بتطبيق خاص. The plasticizers are added to the polymers usually in the liquid phase and as a base. So the materials are oftenly be liquids with high boiling points as well as volatilization. Or even the materials are oftenly be volatilized or highly volatilized and with highly volatilized and with high melting points. The conditions used to be that's supposed to be in the plasticizers are its evaporation while treating with polymer, its vaporization while treating with polymer, and the Phthalic, phoric acid estrates are the most important, the most common plasticizers used in industry or introduced industry. There are actually several of them naturally formed, such as the coal tar. There are actually several of them are naturally formed, such as the coal tar and the fuel oil and the tar oil. When the plasticizer is passing the liquids, or if the plasticizer passed to the liquid at the polymer phase, the disperser or disperser is actually formed, or molecular disperser is actually formed, or even gluey disperser is actually formed. It will possess affinity, ألفة يعني ألفة أو tendency يعني نزعة أو اتجاه للتفاعل مع البوليمر. It poses an affinity towards the polymer. So the scatter will be molecular, which consists of real solutions directly by swelling the polymer at the plasticizers. And if the affinity is actually there will be no smaller this one, there will be a swelling or even a dissolution. It's even better to use mechanical means to distribute the plasticizer in the polymer homogeneously. Thus, the suspended solutions will be thermodynamically will be separated to two independent phases. And that happens right after the separations, after the mixing process, or even after the mixing task, or will take while due to the entire extreme system, or the entire extreme bulk viscosity. It's commonly known, or it's commonly denoted to the ability of the plasticizer to form a real solutions with polymer, or to form a real solutions in affinity with polymers by the term compatibility or even consistency. بالتوافق أو الانسجام. compatibility أو التوافق أو الانسجام. compatibility التوافق، الانسجام هو consistency. So if the polymer swallowed right into the plasticizers, they will be taken as compatible with each other. This compatibility will lead or will result in major drawback on the, as you can see right here for you, even if there was any outer indicators that indicates this compatibility, as you can see right here for you, that indicates this compatibility. يعني إذا انتفخ البوليمر بالملدن مباشرة نعتبر الملدن مع البوليمر متوافقين. If the polymer is actually swallowed within plasticizers right directly or right away, we're just going to have to consider both the plasticizers and the polymer, the swallowed polymers, of course. And by the way, swallowed polymers because we actually mainly here try to concentrate, or mainly here trying to indicate or refer to the swelling of polymer when introduced to the plasticizer, as you can see right here in front of you. They will be taken as compatible components. They will be taken as compatible components, as you can see right here in front of you, or as indicated or as stated here. And this only can be seen by the disambiguations or the by clarifications and necessity to form a real solution of polymers and the plasticizers to reach the thermal particular stabilization. If the quantity goes over, or if the quantity is actually one overflow of the plasticizers, exceeding the concentration of the saturated liquid, running right in the concentration of the saturated solutions, which means the optimal limit or the optimum limits. So the overflow quantity will be grown, or even will be enhanced from the model by using the manufacturing or usage, or even by using reservoiring. الخزن. So if the added quantity of the plasticizers is actually exceeding the, as you can see right here in front of you, or even running right into the concentration of the saturated solutions, which means the optimum limits, so the quantity or the overall overflow quantity will be grown up or even will be enlarged will be radiated out of the model by using manufacturing or even the utilizations or even reservoiring, as you can see right here in front of you. And as you can see right here in front of you, the curves of the polystyrene systems, or the curves of the polystyrene bulks, with phthalates, plasticizers, dimethyl, dibutyl, dioctyl, dihexyl, and didecyl phthalates, as you can see right here in front of you. Using multiple methods or using a multiple quantity of certain plasticizers, or mainly associated to the phthalates, which is the functional group by the way, to be indicated for, or to indicate for is better for us to indicate for, to indicate to. The phthalate is a functional group here with the plasticizers to be added to the polystyrene bulks here in order to enhance the mechanical properties, or even to represent the an optimal addition, or the optimal functionality, introduce the optimal functionality for the polystyrene to be very much affected in certain field of application. Here, as you can see, the curves of the polystyrene bulks. The polystyrene bulks actually by using the dimethyl and the dibutyl and the dihexyl and the dioctyl and the didecyl phthalate, as you can see right here. Didecyl phthalate. Didecyl phthalate will be at the major amount, or the peak amount of 40, as well as the dimethyl will be at the peak amount of 40, as you can see right here in front of you. The in-between amounts will be represented, or even the in-between amounts, يعني كميات, the in-between quantities of the plasticizers added, يعني من الكميات الملدنات المضافة سوف تمثل بالخطوط 2 و3 كما ترون. 2 here indicates, or 2 here indicates the dibutyl, as well as the 3 here indicates the dihexyl. At certain amounts, or even at certain amounts of the angular concentration for the entire bulk solutions, as you can see right here in front. Solution for polystyrene, of course. يعني solutions تركيز البقعة أو تركيز المحلول البوليمري البوليستيرين المعروف جدا الذي يسمى البوليستيرين، الذي يطلق على تسميته، اصطلح بتسميته البوليستيرين. The curve of polymer coexistence with the plasticizers is a facilitated task. That's why the heat of adsorption, or the heat of confounding will be determined at any certain or any particular concentration of the solutions at any particular point of the curve. Confounding هو الامتزاج أو المزج، حرارة المزج. The critical temperature is called the critical temperature of the solution is denoted as Tc. The plasticizer will be divided most times into primary plasticizers and secondary plasticizers, and even dissoluble plasticizers. And the first category, such as the primary plasticizers, is actually including the plasticizers actually used to melt or even dissolve the polymers limitedly. Where the second is strictly functionalized, or where the second is actually strictly affecting the plasticizers that actually used to interact or even to interference with the polymers limitedly, causing or even result in a partial swelling. Third, the castor oil. The castor oil, which is considered a very unsolved or a very dissolvable or a very dissolvent plasticizer for the cellulose nitrates, as you can see right in front of you. The very secondary plasticizers actually used to be functionalized, or even used to be very, very much effective at the presence of another liquids, maybe dissolvent or dissolvent, or maybe a solvent or insolvent for the polymer. The aspects or even the technique strategy is actually used worldwide industry on a broader range, an industry where the plasticizers are plasticizers, or in a particular plasticizer is actually added we've taken dissolvents or solvents to the polymers required to be plasticized instead of adding, as you can see right here in front of you. When the polymer or the mechanism of plasticization, آلية التلدين. When the polymer is actually came in contact with the plasticizer molecules, the plasticizer molecules will begin during the while or throughout the polymer phase or the polymeric phase, if they were actually pretty much compatible, or if there was actually affinity in between them both. So if the affinity is as maximum possible, so the plasticizer molecules will be distributed between the major or the large structural particles only, and the type of plasticization will be termed as the interstructural plasticization. And in case of the crystallized polymers, so the strategy will be denoted oftenly or mostly as the interbundle plasticization. And if the affinity is at climax, so the climax يعني affinity في أقصى ما يمكن, so as climax as possible or as max as possible, so the plasticizer molecules will be interbundly penetrated themselves, and the task or even the strategy is denoted as the interbundle or the intermolecular plasticization. Here, the plasticizer molecules will penetrate within, or will penetrate, the plasticizer molecules will penetrate the bundle themselves, or penetrate through the bundle themselves, or not through, will penetrate the bundles themselves, and the task or even the strategy or the technique used is termed as the interbundle or intermolecular plasticization. The oscillations of the glass transition temperature is actually a very efficiency or measurement for plasticizer efficiency. The efficiency will be displayed clearly in the case of polymerization or the hard chain polymers, where it will be escalating, or it will escalate their glass transitional temperatures. Relevance of TG for nitrates with the quality of the added plasticizers. علاقة TG لنترات السليلوز أو علاقة درجة انتقال الزجاجي لنترات السليلوز مع نوعية الملدن المضاف موضحة بالمثال الآتي is actually very much explained with the following graphical figure. موضحة بالمثال البياني التالي. TG and the percentage content, يعني محتوى النسبة المئوية أو محتوى بالنسبة المئوية. TG is a percentage, or TG is plotted right to the vertical axis represented by y-axis, or denoted as y-axis, as well as the percentage content is actually denoted or plotted to the x-axis, as you can see right here in front of you, with the certain values that are actually ranging from 0 to 25, as well as TG is ranging from 0 to 80, 0 to 40. Coaster oil, زيت القروان. Percentage content. The effect of plasticizers actually substantially depend on the free volume according to the following equation. The plasticizer effect or the plasticizer influence pretty much or substantially going accordingly with the free volume according to the equation stated here. يعني حسب معادلة المرات. TG for the polymer, TG is a glass transition temperature أو درجة الانتقال الزجاجي للبوليمر يساوي TG by equals to TG by P for the polymer. K, as you can see right in the plus. K is a constant to be added. Constants accordingly, or constants been determined according to the type or the sort of polymers used, or the sort of polymer used for the empirical trial. يعني الثابت K حسب نوع البوليمر المستخدم. VF is the free volume. VF, free volume of the plasticizers. TG value for the bulk is actually for the plasticized bulk is actually increasing more with less value of denominator, or less value, as you can see right, with more value of denominator, and the more value of or more VF, or more value of VF, as you can see right for you. The free volume is free volume of the liquid is considered as a particularity of big importance, or particularity of maximum importance, but the amount of the thermal volume ratio is necessary. So the specific volume will be increased with any instant increase in molecular weight. The increment will be due to where the increment will due to the increase, or to the overwhelming size, or the occupied volume, as well as the free volume of the polymer should be escalated with any, should be overwhelmed, or even should be increased with any increase in temperature. Here's actually a very important topic here, or very essential topic, or a topic of maximum essentiality to refer to. The gases permeability, or aerosols permeability. نفاذية الغازات. تفسر نفاذية البوليمر لغاز معين. Polymer permeability of certain gas can be explained as the gas adsorption. The gas adsorption by polymer. Adsorption. هناك فرق بين الابزوربشن الذي هو الامتصاص، كلمة الامتصاص، وكلمة الامتزاز. الامتزاز هي الادsorption of the gas by polymer. Configuration of the solution within the polymer, or formation of solution in the polymer, solution to the polymer, which means the dissolvent or the solvent material, the solvent mass permeability with it throughout the polymer, then desorpted from the other side of the from the second side of the polymer, from the sheet that actually used to be used to work, or used to